All right, welcome to The Explainer. Today, we are diving into a technology that's poised to fundamentally change how we interact with computers, taking AI from just thinking about things to actually doing them. And if you're an engineer building our digital world, well, this is a change you're going to want to pay close attention to.
Let's just kick things off with this quote from Bill Gates. And look, he's not just talking about some minor software update here. He's calling this a revolution, on the same scale as moving from old-school command lines to the graphical interfaces we use every day. That really sets the stage for the massive shift we're about to explore.
So let's kick things off with the big problem, the paradox really, at the heart of the AI we're all using right now. I'm sure as engineers and designers, you felt this pain yourself, this frustrating gap between how smart an AI seems and its ability to actually get anything done in the real world.
And this right here is the heart of the problem. I mean, we've built these AIs that can think with incredible brilliance. They can write code, they can analyze data, offer amazing insights, but when it comes to actually doing something, they can't lift a finger to help. It creates what's called an execution gap, where we become the hands for the AI's brain. We're the ones left to do all the manual work.
Okay, in this example, it just nails the frustration perfectly. Think about it. An AI plans this amazing, flawless vacation to Greece, but has no idea if the hotel it picked is actually, still in business. So what happens? You get stuck with the grunt work. You're bouncing between dozens of websites trying to make the AI's fantasy a reality. The machine gets to do the dreaming, and you're left with all the work. Sound familiar?
So how do we bridge this gap? Well, this is where Agentic AI comes in, a whole new class of AI that's built from the ground up not just to think, but to do. This is that big leap we were talking about, from having a creative brainstorming partner to having an autonomous digital teammate.
So the key thing to get here is that Agentic AI is all about execution. It's designed to take a goal, break it down into a plan with multiple steps, and then, this is the magic part, autonomously use tools like APIs or a web browser to actually get it done. So for you engineers, imagine an agent that gets a bug report, and instead of just suggesting a fix, it actually scans the code base, finds the problem, researches solutions, writes the patch, runs the tests, and then submits a pull request for you to review. That's the world we're moving into.
And this chart, it lays out the difference perfectly. Think of it this way. Generative AI is like a super smart intern. You have to give it a new instruction for every single task. Agentic AI, on the other hand, is more like a project manager. You give it a high-level goal and it just figures it out. It remembers the context, it plans the steps, and it sees the whole workflow through to the end.
Okay, so to really wrap our heads around this evolution, especially from a systems design point of view, engineers have come up with a really helpful framework. And hey, if you've ever designed complex systems, this whole progression from simple automation to full autonomy is going to feel super intuitive.
The best way to think about this is to look at self-driving cars. We have those well-defined levels for car autonomy, right? From level 0, which is fully manual, all the way up to a car that can handle anything. Well, we can apply that exact same logic to AI agents. It gives us a really clear roadmap of what these systems can do.
And here's how that framework breaks down. At level 1, you've got your basic rule-based stuff, think robotic process automation. Level 2 starts to get smarter. It brings in things like natural language processing. But the real game changer is level 3, what we call agentic workflows. This is where the AI starts to plan and adapt on its own. And by the time you hit level 4, you've got agents that can actually learn from what they do and change their own strategies. Kind of like a self-driving car that's fully autonomous, but maybe only in a specific city.
Which brings us to something really interesting called the instruction paradox. It's this wild idea that the smarter and more autonomous the agent gets, the simpler your instructions become. For all you engineers out there, this is huge. It's a massive shift away from writing super detailed line-by-line code and moving towards just defining high-level goals. You're not programming anymore, you're delegating. Okay, check this out. This is a peek inside an agent's thought process during an experiment. You can see it right there. It's analyzing its progress. It's noticing things like demand has increased and funds are steady. Then it reevaluates its whole strategy, deciding, okay, I'm going to focus on manufacturing, and then look at the bottom part. That's where it turns the plan into action. It's using its computer tool to literally execute clicks. It's that whole loop, observe, plan, act, happening over and over again in real time.
So the big question is, what does this all mean for us, especially for the engineers who are actually going to be building these systems? The short answer is, it signals a whole new era of collaboration between us and our machines.
This diagram, I think, visualizes that future perfectly.
See, it's not a competition. It's not AI versus humans. It's all about that sweet spot in the middle, where our skills and the AI's capabilities overlap. The AI can handle the heavy lifting, the data crunching, the automation, and we bring what the source material here calls humics, those uniquely human skills. That intersection, that's where the magic, the real innovation, is going to happen.
So what exactly are these humics? Well, they're basically the stuff that AI, at its core, just can't do. We're talking about genuine creativity, not just mixing up existing data, but coming up with something truly new. We're talking about critical thinking, the ability to look at what an AI produces and ask the tough questions. Is this biased? Is this ethical? Will this actually work long-term? And then there's social authenticity, building trust, empathy, real human connection. For an engineer working in this new world, these skills, they become your superpower. They're what allow you to provide the strategic direction and the quality control that these powerful agentic systems absolutely need.
All right, so let's wrap this up by looking ahead, because what we're talking about isn't just a new tool. It's a fundamental paradigm shift, especially for those of you who are literally architecting our digital future.
And that's going to require a totally new mindset. You know, for decades, the mark of a great programmer was their ability to give a computer flawless, detailed step-by-step instructions. But the skill of a great agentic systems architect, it's going to be more about mentorship. It's about setting clear goals, defining the rules of the road, and guiding a digital partner that can actually think for itself.
So, here's the bottom line, and the question I want to leave you with. This technology isn't science fiction anymore. It's here, and it's getting better at a dizzying pace. The challenge isn't just a technical one of how do we make it work anymore. The real challenge, for you as the next generation of engineers and designers, is a human one. It's about the choices you'll make. How will you design these systems not just to automate tasks, but to amplify the very best of human potential?